Today we'll be looking at Module 4, Linux Overview. Now, if you could remember in our previous class, when we talked about Windows Overview, we specified the fact that when it comes to network security, you need to understand the architecture of the various operating systems. The architecture of the operating systems will help you be able to know how to manage the systems. All right. So if somebody is trying to hack your system, for instance, or somebody is trying to cause mayhem or install mayhem on your system, or you are trying to maintain your systems, you need to understand how the operating systems function, and we're able to understand the architectural view of the Windows system. So today we'll be centering on that of Linux. We'll be looking at Linux overview. Now, what are the basics of Linux? We need to understand what Linux is all about. Linux is basically an operating system. It has been created since '91, and the most important thing is that it is open source. Now, what does it mean to be open source? It means that the codes that was used to create this operating system is left open for any other person who can modify it to customize it to his own need. Okay, so that is what it means open source. So you have access to the configuration files, you can play around with it. But Windows is not open source. All right, so Linux is open source. It is fast, reliable, and small. It requires very little hardware resources to run, but very highly customizable, meaning that you can suit it, you can reconfigure it to suit your needs. Now, in server rooms or data centers, or when you are setting up big machines or security systems, is recommended to some extent that you could use Linux, especially when you are good at it. And the simple reason is because you have a lot of leverage in order to manipulate the codes. There are a lot of applications that you can manipulate the setup. So it is not always that you're going to have the default settings, all right? The default settings like we have in Windows. So if I pick Windows 97, for instance, I should know what the default settings are as regards the structure of the operating system. So, but for Linux, I can get the Linux and decide to change that. All right, that is one of the advantages that it has. All right, and it is part of a several platform that can be found devices anywhere. You can find it on wristwatches, on supercomputers, anything. All right, on switches, on routers, you find Linux, and it has different distribution packages, all right, created by different organizations. Now, like we said, Linux is open source, meaning that anybody can acquire Linux at no charge and modify it to fit specific needs, all right? And the Linux command line interface is also very powerful, all right? It gives you access to almost everything that you can do. The user has more control over the operating system. All right, as the administrator user in Linux is known as the root user. This is very important. It's known as the root user. Okay, or supercomputer, and can modify any aspect of the computer with a few keystrokes. It allows for better network communication control, and control is an inherent part of Linux. All right. Now, what does the Linux Security Operations Center looks like? All right, the flexible provided by Linux is a great feature for Security Center. The entire operating center can be tailored to become a perfect security analysis platform. All right, SGIL is the cybersecurity analyst console in a special version of Linux called Security Onion. Now, remember, I told you guys to download this, and we are going to work on it. All right, we're going to work. This is the tool, Security Onion, that we're going to be working so much on. And this is the console that we're going to be using. All right, like you see here, this is the console. All right, the SGUIL. All right, so this is what we're going to be using for all our activities. Now, Security Onion is an open source suite of tools that work together for network security analysts. All right, so we have network interface, network packet capture software. This is a crucial tool for analysts to make. And what do analysts do? They actually examine and analyze packets and verify sniffers, verify threats, verify all sorts of things. All right. So these are tools that the analyst can use in order to understand the detail of a transaction. Another one very common is the Wireshark. All right, Wireshark is another tool, and we are going to use it as well. All right, another SOC tool is the malware analysis tool. Now, these are tools that allow you to safely run and observe malware execution without the risk of compromising the underlying system. So you want to know the behavior of a particular malware, especially from the way how would I put it, the attacker has designed it. All right, so you can run this tool so that it can guide you, all right, without having to cause you problems. All right, then we have the IDS, intrusion detection systems. There are also two for real-time monitoring and inspection. And if any aspect of the currently flowing traffic matches any of the established rules, a predefined action is taken, meaning that you set like rules here, and it will be allowing traffic to pass, you know, and traffic to go out. Now, if the rule matches any traffic either coming in or going out, then it will begin to execute a particular kind of action, either to drop it or to quarantine it or to allow it to pass, or whatever the action you have designed it to do. Another tool in the center is the firewall. All right, remember we have talked about the packet capture software. Now, why am I talking about this? In your several server rooms or your network security center or your data, you need to have these tools as a security professional. You need to have the packet capture software. You need to have a malware analysis tool. You need to have an intrusion detection system. You need to have a firewall. All right. Now, the firewall is basically software that is used to specify, based on the predefined rule, whether the traffic is allowed to enter or how is allowed to enter or leave the network. All right. Then you need log managers like syslog or whatever it is that you're going to be using to keep records of all the files and transaction that is taking place in your security center. Then you need to have a security information and management system, a SIEM, and it provides real-time analysis of alerts and log entries generated by network appliances such as IDS and firewall. All right, so you need like a SIEM. Then you need a tracking system, you know, task ticket assignment editing and recording is done through ticket management system. So security alerts are often assigned to analysts through the ticketing system. So these are what we need in order to set up our network security center. Now, what are some of these tools that we're talking about? Linux computers that are used in security center often contain penetration testing tools. All right, so that's why Linux is a very important operating system that we need to learn. All right, it has so many tools. So one of it is the penetration testing tool, and it's also known as the pen testing. All right, and it's a process for looking for vulnerabilities. All right, vulnerabilities in a network by attacking it. So you set up a network and you want to verify whether your network is safe or secure or whatever, then you run a penetration testing. All right, you have packet generators, port scanners, and proof of concept exploits. All right. Then Kali Linux is a distribution of Linux which contains many penetration tools. So when you are doing ethical hacking as a course, or you are doing cybersecurity operations as a course, whatever of these security software trainings you are doing as a course, you will come across Kali Linux. So it is important that we know how to use Kali Linux very well. All right, so how do you work with the shell of Linux? The shell, the user communicates with the operating system by using the command line or the graphical user interface. And it often starts with the GUI by default, but it hides the CLI from the user. But you can always open the CLI through a terminal emulator, a terminal software application. All right, once you run the terminal software application, then you gain access to the command line platform. All right, so in Linux, popular terminal emulators are Xterm, this eTerm, the Xterm, the Kano, the console, and the Gon terminal. These are most popular terminals that you can use on your Linux in order to carry out your activities. All right, so this is an example of a terminal, but this one is the most common one that you see in maybe Ubuntu, is the GNOME terminal. All right, this one is like the GNOME terminal. So most times when you have Ubuntu, you see. Now, what are some of these basic commands? Like we see the commands that we see in Windows when we're talking about DOS. We have those in Linux. MV means to move a file or directory or folder. You want to relocate it or move it, or you want to rename them. All right, then you will use MV. All right, change mode. All right, this one is change mode or CH mode. All right, now CH mode or change mode is a command that you use to modify your file permissions, whether you want to give it read, write, or executable, or whatever it is, you know. So then you have change ownership, change ownership, change ownership, or CH own. You use it to change the ownership of the file. You know, when you have different users in your Linux, every user has the rights and privileges. So you can pick a particular directory or a particular file and change the ownership. So to do that, you need to use this command. How about DD? It copies data from an input to an output. All right, and then present working directory, PWD stands for present working directory. What it does is that when you are in command line mode, you just type PWD, it will tell you the directory that you are presently working on. So we use it as the PWD. All right, it displays the name of the current directory. Then the PS lists the processes that are currently running in the system. All right, like we have seen in the Windows when we use the CMD, sorry, Control Alt Delete, that takes us to where we see the processes. So PS lists the processes for you. The SU stands for simulate a login as another user or become a super user. So sometimes we use it called switch user or simulate user. So you can use this command if you want to move from your normal user to the root user or to the administrative user. Then sudo, from the word sudo simply means something that looks like. So sometimes there are times you want to run maybe certain commands that require administrative privileges and you don't want to log in as root, okay? So you can run the commands using the sudo command. So runs a command as a super user by default or another named user, that is sudo. Then grep. Grep is actually used to search for a specific character. You are looking for something, you are searching within a particular file. All right, so you can run grep and it will help you to do that. Now, usually grep comes with a pipe. This is like a pipe, sorry, pipe, something straight like this. All right. ifconfig, like in Windows, you use it like ipconfig. That's its sister in Windows, ipconfig. So this you use to see the IP configuration details of the device. So it's used to display or configure network card related information. So if I do ifconfig, it can show me my details. All right. So apt-get means application. Sorry, I say application. Apt-get is used to install applications. All right. You want to get a particular application from the internet. All right. You're searching for the application and you're getting and downloading it and installing it. So you use it. Sometimes you say apt-get install. Then maybe you give the name of the file application. So it's used to install, configure, and remove packages on Debian and its derivatives. All right, derivatives like Ubuntu is a derivative of Debian. All right, iwconfig is also something like the ifconfig, but this one is centered on wireless. All right, it's centered on wireless cards. So used to display or configure wireless network card related configuration. So shutdown, from the name shutdown, is the command that is used to power off the computer and stop all related tasks that are running it. So sometimes you can do shutdown to sleep it, or shutdown to halt it, or shutdown whatever it is. All right. Then this command password is used to change password. You want to change the password, then you use this command. All right. Now cat is used to list the content of a file. All right, and expects the file name as the parameter. All right. So man is like manual for a particular command. So if I say man cat, so I want to see the manual on how to use this cat command. Or if I say man ls, I want to see the manual on how to use the ls command, or man grep. All right, so man is that. All right, ls is like you want to list. All right, ls is just for list, to display the files inside a directory. All right, cd is for change the current directory. You want to change the directory that you are in to another one, so you use cd. Then make directory, mkdir, if you want to like create a folder or want to create a directory, then you use this particular command. Then cp is a command used to copy files. all right, from a particular source to another particular point. MV, we have talked about MV, is used to move files, and then RM is used to remove or delete files. grep, we have talked about grep, used to search for specific characters, all right. Cat is used to list the content of a particular file. So if you say cat, then you give the file name or parameter. All right, so Linux has many different text editors with various features and functions. So some text editors include the graphical interfaces, while others are command line tools only. So each text editor includes a feature set designed to support a specific type of task. So some text editors focus on the programmer and include features such as the syntax highlighting, parentheses, and so on and so forth. So while graphical text editors are convenient and easy to use, command line based text editors are very important for Linux users. The main benefit of command line based text editors is that they allow for text file editing from a remote computer. All right, so this is like an example. All right, so I can remotely log into a particular server and then I can edit whatever text that I want to do. All right, so this one is Nano. This is the Nano text editor. Some of you might be used to it. So the administrator is editing firewall rules. Text editors are often used for the system. All right, so due to the lack of graphical support, Nano can only be controlled with the keyboard, so you cannot use it with the mouse. Now, in Linux, everything is treated as a file. This includes the memory, the disk, the monitor, and the directories. They are all treated as files. So configuration files are text files which are used to store adjustments and settings for specific applications or services, okay? And user with proper permission levels can use text editors to change the content of configuration files. So that's why sometimes you need to change the ownership or change permissions on users. So after changes are made, the file is saved. The file is saved and can be used by the related service or application. Users are able to specify directly how they want any given application or service to behave. When launched, services and applications check the content of specific configuration files to adjust their behaviors accordingly. All right. So the importance of text editor is what we are talking about, and we are looking at, this is like the Nano. All right, and if you look at here, the Nano has all the tools that you need to operate it. You want to operate it, these are the tools. If you do Control X, that means exit. Control O, that means you write out. Control R, read a file. You know, all this, you know, Control K, cut text. And so these are the tools that you need. So the host file contains static mapping of IP addresses. Okay, so the names serve as shortcuts that allow connecting to other devices by using name instead of IP addresses. Now, servers and clients. Now, we know what a server is. It's a dedicated computer that that renders services to clients. So in this server, basically what is in a server is the services. That's why it's called a server. There are different services that are run across it. Some of it might be DNS service or DHCP service or Apache web service or whatever service that you are running inside here. You are running it so that other clients will be able to gain access to it. So other services run maintenance tasks such as log management, disk cleaning, and so on and so forth. So each service requires separate server software. All right, so the server, as you can see here, is like a file server. All right, and this is software that provides clients with the ability to retrieve or submit files. So this is like a file server. So a port is a reserved network resource used by a service. So while the administrator can decide which port to use with a given service, many clients are configured to a specific port by default. All right. Now, in the network layer, the transport layer is the guy that manages the ports. All right. Because in network security, you need to understand this is like the core of it. You need to understand what applications runs on which port and how they run. So by default, there are certain services that run on certain ports. Like FTP runs on 20 and 21. Like SSH runs on port 22. Like Telnet runs on 23. Like SMTP for mails runs on 25. Like DNS runs on port 53. Like DHCP runs on port 67 and 68. You know, TFTP runs on port 69. HTTP runs on port 80. Post Office Protocol runs on port 110. NTP runs on port 123. Then IMAP runs on port 143. It's another mail applications we use on our phones and our systems. Then SNTP for network monitoring runs on port 161 and 162. Then HTTP and HTTPS, especially HTTPS, runs on port 443. Now, you as the network administrator need to know these port numbers when they are open and how to manage them. All right, you can have other services and you can decide to change the port numbers that they function. All right. So clients are programs or applications designed to communicate with a server. All right. So a client wants to get a particular resource from a server, then the client has to pick a particular port dynamically from its own system. And then this server already, this service that is here already has a port that is statically assigned. So based on their port numbers, that is how they are going to now exchange the information that they need. Now, how do you manage servers? So in Linux services, they are managed by using configuration files, like we said earlier. Like here, you see, when we say cat, what are we saying? You are trying to list the content of this particular file, engines.conf. All right. So common options in configuration files are port numbers, location of the hosted resources, and client authorization details. This is very important. And why? Because especially the location. If you don't know the location of the service and how it is structured, it is difficult for you. For instance, you see, I am doing a cut, but I have to take the directory, take the path. It is in etc, engines, and then this is the file name. All right. So if I don't know the path and the structure, it is difficult for me. So when the services starts, it look for its configuration files, load them into memory, and adjust itself to the settings in the file. So the command output shows the portion of the configuration files for engines, which is a lightweight web server for Linux. Okay. So the command output shows this. If I say cat and then for NTP, all right, this is going to list for me the details in the FTP. These are the NTP servers that are running. Okay, so yeah, still talking about service configuration. Now, device hardening involves implementing proven methods of securing the device and protecting its administrative access. Some of these methods involves maintaining passwords, configuring enhanced remote login features, and implementing secure login with SSH. Depending on Linux distribution, many services are enabled by default. So you can stop the service and ensure they do not automatically start at boot. Is another way of hardening device. Hardening is just trying to make it difficult for others to understand the way your services run, and just something out of the default. You are removing all the default stuff. So if by default this application is made to run and you decide to stop it from running at boot up, you are hardening it, okay? So OS updates are extremely important to maintain a hardware hardening, all right? Now, the following basic best practices for hardening your devices. Ensure physical security. Make sure that it's not everybody that gains access to your switch room, your server rooms, your data center, and especially your security operations center. Only authorized and really authorized personnel. All right, so minimize install packages. You only install the package that you need. If you don't need it, do not install it. If by one way or the other you find it installed on your machine, you can disable it. All right, the services that you are not using, you disable them right away. Always use SSH and disable root account login over SSH. All right, so if you log in via SSH using your user account, you can always use switch user to be able to gain access to that. Just give me a second break. Now, keep your systems updated all the time. That cannot be overemphasized. Disable USB auto detection and enforce strong password. All right, this is very, you should not joke around with this. Force periodic password change and then keep users from reusing old password. That way you can set up password policies so that it can help you manage that. All right, log files are the records that the computer stores to keep track of important events. Kernel services and application events are all recorded in the log files. So by monitoring Linux log files, administrator gains a clear picture of the computer's performance. So security status and any underlying issues are always in the log file. So it's important for us to do that. So Linux has a way of keeping that, and it keeps that in this directory, var, all right? var actually stands for variables, all right? So var and then logs and then messages. So it's a directory that contains generate computer activity logs. So you can always check that. And then var log, then authentication logs actually stores everyone that actually logs into the machine. Then var log, then secure. That one keeps logs of SSH logins and errors and stuffs like that. And then var log boot.log. Now we're talking about logs because it is also an important part of security. When your system begins to malfunction or misbehave, you need to know where you need to check in order to get the messages. And these are the logs, all right? Var log, then the messages is actually directory messages that are kept here, information relating to hardware devices and their drivers, all right? It is also very important because due to the low level nature, logging systems such as syslog are not running when this event takes place, are unavailable. So especially when there are hardware issues, this is where you check your logs. All right, then var log, kernel log, all right, contains information about your kernel. Then var log, your cron. Cron is a service used to schedule automated tasks in your Linux. Very important when you want to maybe do backups every day. You want to do cron.daily, you want to do cron weekly, backup weekly, or you want to run any particular task or service, you want to run it periodically at a particular interval, you can schedule it in cron. So when you come to cron, you can get all the details there. All right, then var log, then mysql .log gives you the logs for your database. All right, so this is how your log messages looks like. How does the system file looks like? There are many different kind of file systems varying from properties of speed, flexibility, security, size, structure, logic, and more. The administrator decides the file system type which is suitable for the operating system. Following the table, it shows the system files that are commonly found in Linux, like the file type in extension 2 was the default file system in several major Linux distributions until ext3 came into play. Even though ext2 is still the file system of choice for flash-based storage media, as lack of a journal increases performance and minimizes the number of writes. So the flash memory device have a limited number of write operations. Minimizing write operation increase the device lifetime. That's the device lifetime. We're talking about like the hard drive. All right. Extension 3 is a journal file system designed to improve the existing ext2, and the file keeps a log of all changes to be made. If a computer crashes before the change is complete, the journal can be used to restore the correct any issues created by the crash. The maximum size of ext3 can take up to 32 terabytes. Wow. Now we have ext4. All right. And it was created based on a series of extension trees. While the extensions improve performance of extension trees and increase supported file size, developers are concerned about stability issues and were opposed to adding the extensions to the stable extension 3. The extension 3 project was split into two. One kept as extension 3 and it is normal development, and other named extension 4 incorporated the mentioned extension. All right. Then the NTFS, right, network file system, is actually a network-based system allowing the file access over the network from the user standpoint. There is no difference between accessing a file stored locally or on another computer on the network. So NTFS is open standard, which allows anyone to implement it. CDS was created specifically for optical disc media. CDFS, sorry. All right. Remember, we talked about all these file systems. All right. Swap file systems is used by Linux when you run out of RAM. Okay. So sometimes in Windows, you call it like virtual memory. Not only in Windows, generally, like virtual memory, your RAM runs out, so it goes to your hard disk and borrows a particular amount of space, and then is used as a temporary RAM. So in Linux, we call it the swap. All right, so you use this a lot, especially when you know you have a low amount of RAM. Okay, so while swap partitions can be useful to Linux computers with a limited amount of memory, they should not be considered as a primary solution. Swap partitions is stored on disk, which has much lower access speeds than RAM. Okay. HFS Plus is a file system used, like we said, in Apple. Remember, we talked about it in Apple. So using Apple. Then MBR, Master Boot Record, are located in the first sector of the partition computer. That's where it stores the information about the way the operating system is going to begin to load. All right, and is used especially during booting. Okay. Linux uses file permissions in order to organize the system and enforce boundaries within computer. So every file carries its file permissions, which defines the action that the owner, the group, and the others can perform with the file. So the possible permission rights are read, write, and execute. Okay, read you see it as R, write you see it as W, execute you see it as X. Okay, so the ls command, which is like the list with the space minus L parameters, list additional information about the file. All right, so if you type ls minus L, like you have here, ls minus L minus ls space minus L or dash L. So it gives you the read, the write, the executable. All right. So where you see read, write, executable. So we're going to talk about the format where you have the user, the directory, the file, and stuff like that. The permissions on the user, permissions on the file, and stuff like that. So the first field displays the permission with the space. All right, as you can see here. All right, the second field defines the number of hard links to the file. All right, like number 1 after the permissions. The third and the fourth fields, all right, this is the first field, second, the fourth, where is the third and the fourth display the user, analyst, and group who owns the file. All right, like, so that's third and fourth. So if I can, this is 1, first, second, third, and fourth. Okay, so this user has write permission and executable permission. All right, then the fifth field displays the size of the file, like we see here. Where is it? Okay, let me show you. Like this one here, we said it defines the number of hard links to that particular file. This one here displays the size of the file, right? This one here displays the owner, that is the group, is analyst staff, all right? And then the sixth field displays date, which is this guy here. Sixth field displays the date and time of last modification. And then the seventh field displays the name of the file. So I just did ls space minus L this, and then it gives me this information. So the read writes, this tells me the permissions of this file, and then this tells me the number of hard links, and this tells me the group, the size, and blah 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 blah. So that is how it works. So let's break down that permissions, that role and permissions, where you have read, write, blah 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 blah, like this. Okay, so the dash means that this is a file. That is this first dash here. It's a file. If you see D, it means it's a directory, it's a folder. So like what you see here, this dash here simply means we're looking at a file. This first dash, look at it here. That means we're looking at a file. If it was D, it means that it's a directory. All right, so the first set of characters, read, write, executable, is for the user permission. That is this guys here. So the first character tells us whether it's a file or it is a folder or a directory. The second group of characters is about the user. So this particular user has read, writes, has executable rights. Okay. Then the second, the second set of characters for the group is for the group permissions, as you can see here. this group as read, write, executable. All right. And then the last one is for the others. So sometimes if on this user I see dash, dash, or I see R dash dash, it means this user can only read, he cannot write, he cannot execute. Okay. If on this group I see R dash X, you can read, cannot write, can execute. If I see W and I see dash, that means you can read, write, you cannot execute. All right. So that is what it works. And how is it represented? It's represented based on a calculation in binary or octal, something like this here. So 0 or dash 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 means no access. Dash dash X means execute only. Dash WR, so W is to write. X is usually at the end. R is usually in the front. All right. Then dash WX means read and execute. Write and execute. Then R only means to read only. Then R dash X, read and execute. Then RW, read and write. And then RWX, read, write, and execute. And so that's where we have 0, 1 to 7. All right, convert it to binary. You will get the 7 in binary is this and this and this and this and blah, blah, blah. Okay. So, so if I come for a file, if I come for a file like this, ls minus l, this, so look at it here. I have this dash here tells me this is a file. It's not a folder, it's a file. Is that not so? And the user can read, can write, but cannot execute. Okay. And the group can read, cannot write, cannot execute. Then others can read and then cannot write, cannot execute. That is like the permissions for this. Okay. Now, any symbolic link, also called a symlink or a soft link, is similar to a hard link in applying changes to symbolic links, will also change the original file. So as shown in the command output, use the ln command option -s to create a symbolic link like what we have here. All right, I'm trying to link a particular file. You see, this is a file, this is another file. There are two files. These two files are different files. Okay, so I want to link the two of them. I want to pick the content of one and put in the other. So you see, I say echo. Echo means to bring it. Echo, it is a lovely day. You see, it's in inverted commas. That means I want it to print it. I want it to carry it exactly like this. And then echo this inside my test.this. That is this file. Okay. So I am putting this inside here. Okay. So if I open it, I'm going to see it. So the link command as shown in the output, if we use ln -s, it will create a symbolic link. And notice at the ending of the line text, the test.tsc also adds the line to my desk. So we have a lab activity when we come to do labs. I think from today is Monday. Yeah, from Friday, we should start our labs. We should start our labs on Friday. Okay, so I think this is it. So hard links and symbolic links. All right. Hard links, locating hard links is difficult, but symbolic links shows the location of the original file. All right, hard links are limited to file systems in which they are created. Symbol links can link a file to another file system. So they're trying to tell us like, the soft links or symbolic links are really very effective. How about the GUI? The graphical user interface presents the most Linux is based on the X Windows systems. The X window, also known as X or X11, is a windowing system designed to provide the basic framework for graphical user interface. The X includes the function of drawing and moving window on the display device and interacting with a mouse on the keyboard. X works as a server, which allows a remote user to use the network to connect, start a graphical application, and have a graphical window open on the remote terminal. X does not specify the user interface, leaving it to other programs such as Windows managers to define all the graphical components. Okay, so this is like the graphical user interface. So the concept here is that Linux machines also have the GUI. So this is the GUI, and it has the normal interfaces that we all know. So how do you work with Linux hosts? How do you install applications? Many end user applications are complex programs written in compiled languages. So to aid the installation process, Linux include programs called package managers. By using a package manager to install a package, all the necessary files are placed in the correct file system location. So a package is the term used to refer to a program and all its supporting files. So the command output shows the output of a new apt-get. All right, so package is like the softwares. All right, so the apt-get commands is the command that we use especially in Ubuntu or any of the Debian derivatives. Operating system updates, also known as patches, are released periodically. So it's always good to update. That will give you an upper hand when it comes to security. Modern operating systems will alert the user when updates are available for download and installation. But the user can check for updates at any time the user wishes. All right, so it's important to run your updates. All right, a process is a running instance of a computer program. Forking is a method that kernel uses to allow a process to create a copy of itself. Process needs a way to create new processes. In multitasking operating systems, the fork operation is the only way of doing so in Linux. So when a process calls a fork, the caller process becomes the parent process, and the newly created process becomes the child process. So after the fork, the processes are to some extent independent processes. So they have different process IDs, but run the same program code. It's just one of the way when we were talking about hyper-threading in Windows, this is one of it, okay? So the following table lists 3 commands that are used to manage processes. So if you use PS, it's used to list the processes running on the computer at the time you invoke that command. If you use top is used to list the running processes, but unlike PS, top keeps displaying the running processes dynamically. you can press Q to quit it. All right. The kill command is used to modify the behavior of a specific process. So if you are going to use the kill command, make sure you know the process ID, because the process comes with an ID, it's like a number or something like that. All right. Depending on the parameters, kill will remove or restart or pause the process. All right. You want to stop that particular service from running or that process from running, then you use the kill and then you put the process ID. All right. In many cases, the user will run PS or top before running the kill. So this is done so the user can learn the PID, that's the process ID, of a process before killing it. So this is example. So if I run top, for instance, this is like the ID and then the user. This ID is run by this user analyst. This ID is run by root. This is run by analyst. This. Okay. So if I want to stop a particular process, so you see, even here it will tell me the memory available, the one used, the buffer available, and stuff like that. So if you have like a server, you can check if it's hanging, you can verify it here. So if you want to kill one of the process, you pick the PID. All right, you pick the process ID. So because usually these malwares, when they get hold of the machine, they begin to execute processes. So it's good to know that. So Linux malware include viruses, Trojan horses, worms, and other types of malware that can affect the operating system. So the common Linux attack vector is its services and processes. Okay, so the command output shows the attacker using telnet command to probe the nature and version of a web server. Okay, so there is a telnet to this particular machine in port 80. That means it's a web server because of the port number tells us the web server, and then is connecting to it, and then if you press escape or the character, it takes it off. All right, so and then it tells us on the server on this particular day, this is what happened. This is the file. All right, it's showing in HTML, bad requests, this and this. So it's giving us the output of this particular action. Okay, this particular action. So it's giving us rootkit check is a type of malware designed to increase. Rootkit is a type of malware designed to increase unauthorized user privileges and grant access to portions of the software that could not be allowed. Okay, a rootkit is destructive as it changes kernel code and its modules, changing the most fundamental operations of the operating system itself. Rootkit detection methods include booting the computer from a trusted medium. So rootkit removal can be complicated. So reinstallation of the operating system is the only real solution to the problem. So you just come sudo. This is the sudo command. This is how you can use it. So when you use the sudo command, it will ask you to enter the password for the administrator. So sudo, and then this command is like you use it to install. All right, you are trying to, this / is like you are trying to install. All right, so and then it's trying to tell us not found. That means it's not in this particular directory. Piping commands. Piping is like when you have, look at the pipe here. Look at the pipe. So although command line tools are usually designed to perform a specific, well-defined task, many commands can be combined to perform a more specific task by a technique known as piping. All right, so when you say lists, it's going to list so many things. So you want to narrow down what to list, then you now grep host. All right, so it's going to now look at that. So the two commands, list and grep, are piped together to filter out the output of listing. So this is shown in this output like this. All right. So the pipe puts together two commands together. So Linux, I think that's the end of the Linux class. But I need to say that it is important, very, very, in fact, absolutely fundamentally important that you get used to this particular Linux environment. Now, among the virtual machines that you have installed, the Security Onion and the workstation is the Linux environment, and we're going to be doing some labs to help us play around with some of these commands. So on Friday, we are going to use this Friday to do labs only. All right, so among our labs that we have, we are going to select some of the labs to cover on Friday. All right. So any question? If there's any question, let me know.